Hello folks, welcome back to Precalculus. Today we're talking about Chapter 5, Section 6, and right triangle trigonometry. Okay, so we're actually going to start the day off with a little warm-up, so you're going to pause your video here in a second, and you're going to fill in all the definitions for sine, cosine, tangent, and their reciprocals given the angle x. So for example, the definition of sine is opposite over hypotenuse, so we can write it like so. So go ahead and pause your video and fill in all the other 5 trigonometric functions. Okay, there we go. You can check your answers there and realize that we're just using the SOHCAHTOA definitions for sine, cosine, and tangent, and then just flipping them for the reciprocals, cosecant, secant, cotangent. Okay, so moving on down, we're actually going to do the same thing again, similar exercise. I'm going to let you guys know that angle x is right there. So now we're going to pause using side lengths of A and B and hypotenuse C. We are going to pause the video and evaluate sine, cosine, and tangent of x and then their reciprocals. Go ahead, pause your video and complete it. Okay, there are your answers. You can see, you can check yours to make sure that you're correct. But again, just taking our sine, cosine, and tangent definitions and then flipping them to get the reciprocals. Okay, so let's jump down here and try an example. So the first example here, we're being asked to find the missing angles and the missing side lengths of this triangle. Well, first of all, the missing angle is easy. This is 90 and this is 30. This has to be 60 degrees. Very simple. Okay, now looking at this, and let's just say we want to find A. I'm going to use 30. It doesn't matter. You can use 60 if you want, but I'm going to use 30. I know 30. A is opposite. What I know is adjacent. So I'm going to say the tangent of 30 equals A over 12. In other words, A equals 12 tan 30. Multiply my 12 over to the other side. We know that the tangent of 30 degrees is radical 3 over 3. So our answer is going to be 4 radical 3. We can actually do the same thing with 30 degrees, what we know, and cosine to find C, because we know adjacent and we're trying to find hypotenuse. So I can do that up here. I can say the cosine of 30 equals 12 over C. That means that C is equal to 12 over cosine of 30. The cosine of 30 is radical 3 over 2. And you guys all know how to divide fractions. 12 times 2 over radical 3, which is going to be 24 radical 3 over 3. I'm running out of space, which is 8 radical 3. Now what I want you guys to do here in the next example is pause your video. I'm not going to provide answers for you. This is a right triangle. It's not labeled. We can call it A, B, C, which would mean this is A, this is little b, and this is little c. So you need to solve for angle B. Okay. I'm sorry. I need to give you a piece of information. This is a 4. Call that a 4. Okay, you need to solve for angle B, the hypotenuse, and the base of the triangle. Go ahead and pause your video, give it a shot. I'm not going to give you an answer. We can talk about it in class. Okay, now let's talk a little bit about inverse trig functions. Okay, now we've spent some time extensively on inverse functions this year already. But remember that a regular function, called f, takes an input and assigns it to an output. And an inverse will bring it back. Okay, we'll take that output and assign it to the original input. Okay, now when it comes to trigonometry and trigonometric functions with angles, we input an angle For example, we take the sine of 26 degrees, and we get out a ratio. Well, to use an inverse function, we're going to need to plug in a ratio, and that will tell us the angle that makes that ratio. So remember that with all of these sine and cosine values, I'm just using my unit circle here again. Notice all the sine and cosine values go anywhere between 1 and -1. Cosine values between 1 and -1. So you can't plug in any numbers that are not between 1 and -1 into sine inverse, cosine inverse. We'll talk about that here in a second. Okay, so how inverses work. So if sine of theta is equal to x, then we should be able to take what is called the arc sine of x to get theta. If cosine of theta is equal to y, then we should be able to take the arc cosine of y, and that will give us our whatever angle. And same thing with if tangent of an angle is equal to z, then we can take the arc tangent of z, and that will give us our angle. Inverses are great because they allow us to find angles when all we know is our side lengths of right triangles. Now, one important thing to understand is that these thetas that we get out are going to be different, slightly different, I should say. We need to understand what possible angles are going to be outputted. Okay, so we can talk more in class about this, about the why, and I can do the proof for you and show you where the derivation comes from. But theta, if you use arc sine, theta is going to be somewhere between -pi12 and pi12. It's going to output an angle between -90 and 90, an acute angle. It's actually the same thing with arc tangent. Arc tangent is only going to output acute angles between -pi12 and pi12, or -90 and 90. Arc cosine is the one inverse trig function that is going to output it. It can, and not going to, but it can output a obtuse angle between 0 and pi, or between 0 and 180 degrees. So it's important to understand that arc cosine can output obtuse angles, whereas arc sine and arc cosine cannot. Okay, let's flip over and keep rocking here. So our first example, we're just trying to find the degree of angle x. So we're going to have to take the arc sine of 0.5. And if you're clever, you know that the arc sine of 0.5 is going to be 30 degrees. Or you can use it on your calculator. Just remember to switch your calculator to degree mode by pressing the mode button at the top and going down and selecting degree. So now we got to evaluate the arc cosine of 0.7193. Let's see what we get. 44.0 degrees. It's the same thing holding true here. So the arc tangent of 1.6 is going to be essentially 60 degrees, because we're only rounding to the 10th degree, and you should get, I'm sorry, not 60 degrees, 58 degrees, because we would get 57.99. And to evaluate, all we know is cosecant. Well, if cosecant of x equals 1.4396, then this automatically means that sine of x equals 1 over 1.4396. So we can take the arc sine of 1 over 1.4396 to get x. And we can do that right now. And you should get about 44 degrees if we're rounding to the nearest 10th degree. All right, let's dive in and go ahead and solve some triangles here. First things first, should tell you guys these are right triangles. Okay, and we can use the Pythagorean theorem because we know two sides. So 25 plus 144 is 169, so C is going to be 13. So to find angle A, essentially, since we know all three sides, we can pick our favorite trig function and take the inverse of the ratio, and it'll give us angle A. So what we're going to do here is I'm going to use arctangent of 5 over 12. And if I do the arctangent of 5 over 12, I'm going to get approximately 22.6 degrees for angle A. Which means that if we take 180 minus 90, we get 90, and then take that and subtract 22.6, we are going to get angle B is 67.4 degrees. So go ahead and pause your video, and you'll need this completed for class, but I'm not going to give you the answers, and solve for the missing side A and the two missing angles of this triangle. Okay, let's talk a little bit about cofunctions now. We'll be very brief here, but remember that on your unit circle, that the sine of an angle, let's just say 30, is 1/2, is the exact same as the cosine of its complement. Okay, notice that the sine of 45 is the same as the cosine of 45 because 45 and 45 are complementary. The sine of 30 is the same as the cosine of 60 because 60 and 30 are complementary, and that's going to hold true for the radians as well. So we know that the sine of angle x is equal to the cosine of 90 minus that angle, or pi halves minus that angle in radians. And the cosine of an angle is equal to the sine of 90 minus that angle. Which just means it's going to hold true for the reciprocals as well. So the cosecant is equal to the secant of 90 minus that angle, or pi halves minus that angle. And secant is going to be equal to the cosecant of 90 minus that angle, or pi halves minus that angle. All right, now if you recall back to your tangent, the same thing holds true for tangent and cotangent. Okay, the tangent of 30 was the same as the cotangent of 60 and vice versa. So we know that tangent and cotangent are cofunctions of each other as well. So we get these handy cofunction identities for all 6 of our trig functions. So just doing some quick examples, we know that if we have the sine of 44, that's going to be the exact same number as the cosine of 46. Go ahead and type in your calculator. You'll get the same exact answer if you're in degree mode. Okay, same with secant. So secant of 81 is going to be the exact same as the cosecant of 9 degrees, because 81 and 9 are complementary. Now, these are in radians. I didn't specify that for you, but it's really simple. The cosine of this angle in radians is going to be the same as sine of pi halves minus that angle, 0.4567 radians. And the cotangent of 0.3579 radians is going to be the exact same as the tangent of pi halves minus that angle. Using cofunctions, super simple, straightforward. All right, let's dive into some examples here. Okay, we're going to do some trigonometry here with some baboons. But first, let's talk about angles of elevation and depression. Okay, so the angle of elevation is the acute angle formed by a horizontal line of orientation, meaning looking straight forward. You can see it right here. And the line of sight, which is above the line of orientation. So it should make sense that the angle of elevation is an angle that is elevating or going up. Whereas The angle of depression is the acute angle formed by a horizontal line of orientation. See it up here. And the line of sight, which is below the line of orientation. So it should make sense that the angle of depression is going down. It's depressing. Okay, so let's do a little word problem here. So a naturalist spots a troop of baboons high up in a tree. So she's 300 feet away from the tree. She finds the angle of depression to the bottom of this tree is 14 degrees, while the angle of elevation to the top of the tree is 25 degrees, and the angle of elevation to the baboons is 21 degrees. She's looking up at the baboons. Angle of elevation. We're trying to find the height of her post, so clearly she's in an observation post, the height of the tree, and the height of the baboons. So essentially what we're looking at here, ladies and gentlemen, is we've got this is going to be very poorly drawn. But here's our post, and there's our naturalist. Okay. Girl looking like that. There we go. And then we have this tree along the ground that's got a bunch of baboons in it. So I don't know how to draw baboons, so I'll just draw the eyes of the baboons looking out of the tree. Okay, so her line of orientation is straight ahead. We know that her angle of depression to the bottom of the tree is 14 degrees. It's pretty cool. The angle of elevation to the top of the tree is 25 degrees. No, this is not drawn to scale. And the angle of elevation to the baboons is 21 degrees. So what we can do is we can look at this and say, oh, well, I see a bunch of different right triangles. I'll just do the bottom one right here. I'll draw it. So if we know this is 14, and this is a right triangle, we know that she's 300 feet away. So this has to be 300. We're trying to find out how high up she is in her post, so we'll call this A, since it's part A of the questions. Let's take a look at part B. Says the height of the baboons. That's going to be this 21-degree triangle. So I'll redraw it. 21 degrees, 300 base. And then the total height of the tree, 25-degree angle of elevation. She's still 300 feet away from the tree. And that's going to be part C. So let's just go ahead and do part A first. So how high is she up? We noticed that we want to find the opposite. We know the adjacent, so we're going to be using tangent. So the tangent of 14 equals A over 300. Essentially multiply your 300 by tangent of 14. Do that real quick. And you get 74.8 feet is how high up she is. Okay, so this is going to be 74.8 feet. There's our first answer. Now the second question was, how high are the baboons? That's this one. So we're still going to be using tangent. Tangent of 21 equals opposite over adjacent. So tangent of 21 equals B over 300. Take your 300 and multiply it by tangent of 21. You get 115.16. But that's just this right here, which is from her line of orientation to the baboons. So if we want to know how high they are up in the tree, we need to add 74.8 to it. And you should get 189.96. For how high the baboons are up. And we're going to do the same exact thing for finding the height of the tree here. We're going to take 74.8 and solve for side C. So tangent of 25 equals C over 300. So let's go ahead and take 300 tan 25. Get 139.89. But remember, you need to add your 74.8 to it. So I'll do that on my calculator. And you get 214.69 feet is the total height of that tree. Awesome job, guys. We made it through the notes. If you have any questions, be sure to bring them to class. I'm excited to help you. Have a great day.